Welcome to EDU Aero Classroom. In this tutorial, we will learn about probability. Now, consider the statement, it will probably rain today. Here, it means it may or may not be rain today, but on our past experience, we predict that it will rain today. So, we can say that the uncertainty of probably, etc., can be measured numerically by means of probability. Now, first we will understand what is trial. A trial is an action which results in one or several outcomes. For example, each toss of a coin is called a trial. Now, let n be the total number of trials the empirical probability PE of an event E happening is given by probability of event E is equal to number of trials in which the event happened upon the total number of trials. So, the probability of an event E is given by number of trials in which the event happened by the total number of trials. For example, the probability of number of times a head come up is given by number of times a head comes up divided by total number of times a coin is tossed. Similarly, in case of tail, we can find the probability. Similarly, then we have to find the probability of number of times of one term up when we throw a dice can be written as number of times one turned up divided by total number of times the die is thrown. Similarly, we can find the probability for any number turned up. Now let's do example. A coin is tossed 1000 times with the following frequencies. Head is tossed, head comes 455 times while tail comes 545 times. Now we have to compute the probability for each event. Since the coin is tossed 1000 times, so Here the total number of trials is 1000 times. Let H be the event of getting ahead. So the probability of getting ahead is numbers of time heads come up divided by total number of trials. That is equal to number of heads is 455 and the total number of trials is 1000. So the probability of getting ahead is 0.455. Now let T be the event of getting a tail. So the probability of getting a tail is given by number of times tail come divided by total number of trails. That is equal to 545 divided by 1000 is equal to 0.545. Now if we add these probabilities, that is PH plus PT is equal to 0.455 plus 0.545 is equal to 1. So we can say that H and T are two possible outcomes of each trial. Now let's do another example. A die is thrown 1000 times with the frequencies for the outcome 1, 2, 3, 4, 5, 6 as given below. 1 comes 179 times, 2 comes 150 times, 3 comes 157 times and so on. Now let EI denote the event of getting the outcome I. Which is equal to 1, 2, 3, 4, 5, 6. So now probability E1, that is the probability of outcome of 1, is given by frequency of 1 divided by total number of times the dice is thrown. So it is equal to 179 divided by 1000, that is equal to 0.179. Similarly, probability for outcome of 2 is given by frequency of 2 divided by total number of times the dice is thrown, that is equal to 0.15. Similarly, probability for the outcome of 3 is given by frequency of 3 divided by number of times the dice is thrown, that is equal to 0.157. Now the probability for the outcome of 4 is given by the frequency of 4 divided by total number of times the dice is thrown, that is equal to 0.149. Now similarly, probability of getting 5 is equal to frequency of 5 divided by total number of times the dice is thrown, that is equal to 0.175. Similarly, probability for the outcome of 6 is equal to frequency divided by number of times the dice is thrown, that is equal to 0.19. So here we observe that PE1 plus PE2 plus E3 plus probability of event 4 plus probability for event E5 plus probability of event E6 is 1. So we can say that it covers all the possible outcomes of a trial. So we can say that the probability of each event lies between 0 and 1. The sum of all the probabilities is 1 and event E1, E2 up to even covers all the possible outcomes of a trial.